Hi everyone, this is Mrs. Eggerding. You're watching Unit 3, Video 5, and we're going to talk about solutions to quadratic equations, which again should be a review of Algebra 1, but we're going to add a little bit to it, I hope. We just finished talking about how to graph things in standard form by starting with the axis of symmetry, which is x equals the opposite of b over 2a. And in this case, that's opposite of 2 over 2 times 1, or negative 1. And we can use that value to build our chart, because we know the negative 1 will be our vertex, and we can build around it. If I take negative 1, I get 1 minus 2 minus 8. That's negative 9. If I plug in 0, I get negative 8. And so by symmetry, I can keep building it. Plug in 1, I get 1 plus 2 minus 8. That's negative 5. And if I plug in a positive 2, I get 4 plus 4 minus 8. That's 0. We go ahead and plot those points to get our parabola. And what we are interested in are finding these x-intercepts at 2, 0 and at negative 4, 0. Now it so happened that in our chart we ran into these numbers here, but the question is, are there other ways to find them? Or what happens if they're not at integers? That's where the zero product property comes in. Zero product property states that if I have two quantities multiplied, that's where the product comes from, to equal 0, then I know one of them has to be 0. Now this 0 is important in here because this 0 is talking about our y-coordinate being 0, which is a definition of an x-intercept. So when we're using the zero product property, we are in fact finding x-intercepts because we're talking about when the y equals 0. So here's the one we just did, x squared plus 2x minus 8 equaling 0. That means I want to find when a y-coordinate is 0. This one does factor nicely, x plus 4, x minus 2. So now I have two quantities being multiplied together to equal 0. Zero product property then says each one could be equal to 0, and it gets me my two solutions, negative 4 or 2, which are the exact x-intercepts that we found on the previous page. So if we take a look at this one, 2x squared minus x minus 15 equals 0. We have the equals 0. That tells us we're looking for the x-intercepts. But if I wanted to make a chart with this, opposite of b over 2a is not going to get us a nice number, and I'd rather not build with that. So instead I'm going to try to factor. Go ahead and try this on your own. Pause your video. When you have finished factoring it, go ahead and start it up again and see what you get. So here are my factors, 2x plus 5, x minus 3. By the zero product property, I'm going to get 2x plus 5 equals 0, or I'm going to get x minus 3 equals 0. That gets me two values of x, negative 5 over 2, and x equals 3. And these are the x-intercepts of this function. Notice one of them, the negative 5 over 2, isn't an integer, and had we built a table to try to graph it, the x-intercept wouldn't show up as easily as they do when they're integers. So let's take a look at this next one. Negative 6x squared plus 7x equals negative 10. Now at this point it's not asking me to find x-intercepts because I don't have a 0 anywhere. One thing I could do is go ahead and add 10 to both sides. And now I am talking about the x-intercepts and can go ahead and use the zero product property. But if I went to factor this negative 6 out in front is not making me happy. So I'm not going to use that version. I'm going to go ahead and move the negative 6x squared over to make a positive 6x squared, which means I have to move the 7x over, and the negative 10 is positive. Now it's equal to 0, which means I'm talking about x-intercepts, which is what I'm looking for. Go ahead again, pause the video, factor this any way you know how, start up the video again, and check your solution. Okay, so I factored mine and I got 6x plus 5, x minus 2. Zero product property says I can set each one equal to 0, and I get two solutions for x. X is negative 5 over 6, and x equals 2. These are the x-intercepts of that parabola. Now, the zero product property can be used in some special cases. For instance, if I see x squared plus 25, I can go ahead and make this equal to 0, which gets me the difference of two squares. So that factors nicely. And I get two solutions. X is negative 5, or I get x is positive 5. Now, most of you should recognize that those are the two square roots of this. So a special case of the zero product property gets us what we call the square root method. And the square root method says that if all I have is a squared on one side, I can simply undo it by taking square roots. And you do have to remember that it's both the positive and the negative 5 that works in there. Now in this case, neither method was better than the other. They both work. But in a case of something like x squared equals 17, if you tried to bring it over and set it equal to 0, I don't happen to have a nice way to factor that. So again, square root method says that I can go ahead and simply take the square roots of both sides, and I will get the positive and negative square root of 17. Those are the x-intercepts of x squared minus 17. Which kind of brings us back to our original problem. If I did write it as x squared minus 17 equals 0, does this factor? Well, now we can actually say it can. X minus the square root of 17 and x plus the square root of 17. So it factors, it just doesn't factor with integers. Kind of a little fun side note. So other cases of the square root method involve when you have a quantity being squared. I could make this equal to 0 and multiply it out, or, because it's a quantity squared, take the square root of both sides. The square root and the squared cancel out, so I'm left with x minus 4, and it's going to equal positive 6 or negative 6. Now I didn't write it as a plus or minus here because when I go ahead to get the x by itself, I need to add 4 to each value, both the positive and the negative. One of them gets me a positive 10, the other one gets me a negative 2. So in this case, keeping those two separate, the positive 6 and the negative 6, helps me get my answer. More complicated instance is something like this, where the first thing I need to do is get this x by itself. So, and if you can hear the phone in the background, it's right before election time, and so Washington, D.C. is calling me. Now that I have the x squared by itself, I can take the square root of both sides. I'm left with x plus 1, and I have the positive and the negative square root of 10. Okay? I don't need to get the decimal equivalent. When I subtract the 1 from both sides, I'm going to leave that out in front so I don't confuse that with the square root. And here are my two x-intercepts of that. Not pretty, but it works. Alright, so your assignment on page 124, 13 to 21 odd, you're going to have two types of problems. Some problems you're going to factor and then use the zero product property. Some other ones you're just going to use the square root method. We'll talk about your questions in class, and see you then. Thanks a lot.